So you can see here from the title of the lesson, forms of linear equations, and the fact that I've kind of got three sections broken down here. We are looking at three different forms of linear equations. Now, depending on who taught you Algebra 1, you may or may not have seen all of these, but we're going to kind of review them in this lesson, and then the next half a lesson, we're going to try to tie that back to our Algebra 2. Okay. Let's focus it in. Lock it in. All right. Now, here are our three names up here. We've got point slope form, slope intercept form, and standard form. These are three different viewpoints at the same statue. Okay? So let's just start with the head-on one, the one that we're most familiar with. And this is the easiest one for us to roll through. Okay, so we're going to talk about when these different formats are helpful for us, because it's not just about having different formats, it's about which ones are the most helpful in certain situations of which you're going to be applying these in your homework, okay? So let's start with the slope-intercept one. This one is used when we know the y-intercept and the slope, which we're also going to call rate of change, because you're going to see that in some of your questions today in your homework. There's going to be this rate of change, or a certain way things are changing, right? And when it's a rate, we're talking about a fraction or a comparison of like a ratio top to bottom, right? Okay, and so maybe it's amount of water flowing out per minute, or it's the number of flowers gathered per trips to the field. I don't know, whatever the ratio is, okay? But the rate has to do with this idea of one thing being compared to another. Now, try to set your notes up the way that I do, so that, because I'm going to write different things in different spaces. So I'm going to offset this just a little bit here to the left. So here's our generic slope-intercept format. And I'm going to put a little squiggle here, and then I'm going to use my highlighter to indicate the important parts of my slope-intercept format, which are my M and my B. And of course, my M is going to be my slope, and my B is going to be my y-intercept, which most of the time we will just write 0, B, because I want you to be clear that when we talk about that value, we're going to write it as an ordered pair. That communicates that it's a y-intercept. So y-intercepts are points on a graph, so we're going to write them as ordered pairs. Okay? All right, now, linear equation, linear function, we've talked about this idea. These things are the same. There are inputs and outputs. We're not using function language today, but be clear that this x must remain a variable, because that has to be the input to the function. And this y must also remain a variable in our format, because that needs to be the output of the function. So the idea is we need a number here and a number here so that we can then do some math in our function machine. So I can take an input, drop it in here, process the math, and ding, out comes an output like that. All right? So input, ding, out comes the output. All right? So keep that in mind, that that's what we're working at. Now, let's use an example. Okay? So here's an example for you. Y is equal to negative 9/4 x plus 4. Y is equal to negative 9/4 x plus 4. Okay, so let's use our highlighter and identify our key pieces of information. So we'll jot those down over here. So our slope is going to be negative 9/4. Now that negative, right, can be applied to the top or the bottom. So I want you to think of this as, you can think of this as negative 9 over positive 4, or positive 9 over negative 4. Either one is going to get you to the same place. Thanks. Okay, but it's negative 9/4 is our slope. Now, I will tell you this. When you're typing these into formative, and when we're writing linear equations, you're going to write it where the negative sign is out in front of your fraction. You only apply it inside the fraction like this to help yourself do your rising and running, okay? Like this is down 9, right 4. Down 9, right 4. Wait, that's backwards for you. Down 9, right 4, right? But if I go down 9 and right 4, but if I flip that up, then I'm going to go up 9 and left 4. You can see that I'm still on the same line, okay? And that's the idea of why the negative stays out front. Now, we know that our y-intercept here is going to be 0, 4. Okay? Everybody good so far? This should be easy, right? Big review. Okay. All right, so let's do this. We're going to say to graph, and then in parentheses, we're going to put heads to tails. And so then let's be clear about our heads and our tails. So for example, I'm going to highlight this right here in green, and I'm going to write heads. All right, this is the algebra side. So the y equals negative 9x plus 4 is the algebra side. And so then down here is where I'm going to find my tails, and the goal here is to go from heads to tails. So I want to go from my algebra side, from this to my graph, to create a picture of the equation y equals negative 9x plus 4. All right, so let's just jot down some simple steps. So the first thing we're going to do is we are going to plot, which means to draw a point at 0, b. And then we are going to rise and run according to our slope. And it is optional if we want to do it 2 times. That helps us get our lines nice and straight. That's usually if we can rise and run 2 times. But so this is pretty simple to plot this and to graph this, right? So we know that our, from our question up here above, we know our y-intercept is at 0, 4. So I'm going to come up and I'm going to go 0 on the x, 1, 2, 3, 4, and I'm going to put a point right there. And then I'm going to rise and run. Okay, well, it looks like I'm going to have a hard time going up 9 and left 4, so I'm probably going to have to go down 9 and right 4. So I'm just going to count down 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4. And then I'm just going to draw my line through those 2 points. And then get some arrowheads on our lines. Let's label our points that we're using, 0, 4. And let's see, this point is 1, 2, 3, 4, 1, 2, 3, 4, 5. So this is 4, negative 5. And so I have my 2 points for my line. So I started with an equation and I produced a picture, heads and tails. Now, the other thing I'm going to ask you to do is start with a picture, tails, and go back to heads. So you got to be able to do both sides. You got to be able to go both directions, all right? So let's talk about how we're going to do that. So to slope-intercept, and again, this is going to be tails to heads. We're going to reverse this process. So the first thing we're going to do is we're going to find our 0, b. So we want to know what that number is, our y-intercept. Then we're going to find our slope. We can do that a number of different ways. We can use our slope formula. We can just count, rise, and run. I'll let you decide how you want to do that. And then lastly, we're going to take those 2 numbers and we're going to plug them in to our format for slope-intercept form. Okay, so here's what that's going to look like. And this is how I want you to write this. Okay, so we're going to go like this. We're going to go y equals box x plus box. And then up above here, I'm going to write a little m. And then up above here, I'm going to write a little b. And this is where I'm going to switch colors, right? And the reason why I'm doing this, you'll see as we move along why this is important, okay? So in this case, I'm going to write my generic, and then I'm going to go plug my two pieces of information in here, right? So I know that my b, my finding my b is going to be a 4. So I'll write that in here. And then I know that I did my slope. We just calculated it. We know it's down 9 and right 4. So we'll go minus 9 and 4 like that. And then once we have our pieces in the right place, we will write our final version of our slope-intercept linear equation with our negative sign out front. And there you have it. Heads to tails, tails to heads. Okay, now, if you've learned anything about me in teaching math, it is I'm going to show you how to do it the easy way, because once you know how to do something the easy way, you can see a pattern that will help you do things the harder way. Okay? So slope-intercept form is easy. You should already know how to do everything we just wrote down up there. But it's a good reminder because now we can follow this same process to go heads to tails, tails to heads in both of our other formats. Okay? What's that? All right. So let's talk about point slope form now. Okay, so this is a different point slope form. This is a different format of a linear equation. So this is used when we know, and I'm going to do this capital N-E underline point and our slope, which to reinforce again is our rate of change. I say, well, okay, Ms. Fargus, how is this much different than the other one if we know any point and the y-intercept is a point? Very good question. Glad you asked that. So we really use this when there is no clear y-intercept. So when we don't have a really obvious y-intercept, this is where point slope comes into play, because if we can find any point that we do know is obvious, we can use this to write a linear equation. All right, so let's talk about the generic format of point slope form. It's going to look like this. And again, I'm going to offset this to the left just a little bit here. So it's going to be y minus y sub 1 is equal to m, and then in parentheses, x minus x sub 1. All right, let's give ourselves a little squiggle here. All right, now, let's highlight this one. We know what this is, right? Okay, good. All right, this is m is m is m is m. All right, so m is our slope. All right, now I'm going to highlight, now really important you do this. Do not include the signs, just like that. Just like that. You're going to see why this is important in a little bit. Okay, what do you think those other two things are that I boxed in up there? It is a point because it's an x coordinate and a y coordinate, right? It is the any point that we know, okay? So our point of point slope is going to be x sub 1 comma y sub 1. Okay? All right, let's do an example. So let's say I gave you this equation in point slope form. Y minus 3 is equal to 5/7 x minus 1. Okay? And, just for the record, we can do this. We'll just highlight this whole box here like we did on the other one. And this is heads, right? Because this is the algebra side. Okay. Okay, so we need to highlight the important pieces of point slope. Do you know what they are?
Yes.
Okay. Give me one of them. Okay, 1. That's one of them. 3. That's another one of them. I did not include the minus signs, did I?
No.
Right, very important. And then 5/7. Yeah, that's the other one, right? Okay. All right, so now let's just make a note like we did over here before. So now we know that our slope for this problem is going to be 5/7. And we know that the point, I'm just going to abbreviate that PT, the point is going to be x1, y1. Okay, well, what did I box in here? Well, I boxed in a 1. What kind of a 1 is that? Positive or negative? That's a positive 1 in there, right? Because it doesn't have a negative sign in front of it. Maybe put a couple little pluses in there to help you remind yourself of that. So this is +1, +3. Okay? And just like with a y-intercept, if I have a place to land on the graph, I can rise and run, right? Okay, so let's jot that down. So to graph, again, to go from heads to tails. Okay, so to go from heads to tails, we are going to plot our point that we pull right out of our equation, so our x1, y1 point, and then we are going to rise and run. And again, this is optional. Do this 2 times if you want to keep things really nice and neat and organized. And again, we're going from heads to tails, so I'm going to draw my little arrow here, and I'm going to... No, you didn't see anything. You're not seeing anything. You're just having weird flashes. That's the one downside to this program, is if I have anything else open, it flashes up there when I start scrolling. Okay. All right. Okay, so plotting x, y, right? So we could do this. 1, 3. So let's find our point 1, 3. So 1 over 1, 2, 3 up. All right, and that's my point 1, comma 3. And so now I need to rise and run. So what am I doing? Am I going up 5 and right 7, down 5, left 7, left 5, right 7? What am I doing? Which one's on the top? Up or down? Okay, up 5. Good. Okay, so 1, 2, 3, 4, 5. And then right 7. 1, 2, 3, 4, 5, 6, 7 out here. Oh my gosh. That's horrible. No, it's 5, 7, not 6, 7. It's 5, 7. 1, 2, 3, 4, 5. Right. Okay, all right. Thought I did that wrong. That'd be terrible if I did 6, 7. Okay, what's that address? Yeah, what's that address of that point out there?
Of that one way out there?
Yeah.
7, no, 8. 8.
8, 8. Okay, all right, let's label that.
8.
8, 8. Okay, all right. So then we can draw a line, right, from our point out here. I can even extend my line a bit here, right? In fact, okay, so what if I didn't go up 5 and right 7?
You could have gone down 5 and left 7.
Okay, all right, let's try that. So down 1, 2, 3, 4, 5 and left 1, 2, 3, 4, 5, 6. Hey, look at that, right on the line. Okay. 5, 7. Okay. So what's that address? Yeah, okay, good. -6, -2. Okay, good. All right, so we went from heads to tails. That's pretty easy, right? It's just being able to pick that point out of the equation and making sure that you have your slope. You get a point and you rise and run. So it's a lot like y-intercept, except you don't have the y-intercept. You just have another point, right? No, not today. No, not today. Okay, all right. I forgot to draw my little arrow over here in my highlighter. I'm gonna draw a little arrow here to go from tails to heads. Let's do the same thing because we're just get this flow happening here, right? Okay, so let's talk about going from tails to heads now. So let's go back to point slope, right? So this is tails to heads. That just so you're aware of what we're doing here, I'm going to ask you different questions. I'm going to say, here's an equation in one of the three formats. Graph it. Then I'm going to give you a question that says, here's a graph. Write the equation in.
Will you tell us the
Yeah. Well, sometimes I will. And then sometimes I'll say, which format is best for this kind of graph? And that's where this information at the top comes into play. Do you have a clear y-intercept and a rate of change? Use slope-intercept form. Do you have a non-clear y-intercept, but you have another point and a rate of change? Use point-slope form. This is what you're going to have to know is when to use which one. Okay? All right. But let's talk about right now the mechanics of getting back to point slope. Okay? So the mechanics of getting back to point slope look like this. Whoops, let me underline this. All right, so we're going to first find a point, and then second, we are going to find our slope, which again, you can calculate in multiple ways, right? I'll let you figure out how to do that. And then lastly, we're going to plug it into this format, our point slope format. Okay, based on those instructions right there, can anyone foresee a problem? Pick a point, find the slope, plug it into the format. What was the original? We want to get back to the original equation, right? What was the original equation? Oh. No, we don't. In fact, with this one, right, Lauren, we said in the beginning, right, we don't have a clear y-intercept. That's why we're using this one. Okay. Margo, you had your hand up?
Well, there's multiple points.
Uh-oh. There's multiple points. Okay, wait a second. So let's do this. Let's just break this into two sections. We'll just go with two sections. What was, like, if we were just, I mean, we could pick randomly, right, multiple points, but let's just say, like, which point would be get us back to, like, the original equation the way we started?
I think
1-3, right? Because that's the one that we first came from heads to tails with, right? Okay, so let's just pretend that we use 1-3. So let's write a generic, kind of like what we did over here. Let's go like this. Let's go y minus, and then we're going to put a box, equals, and then we're going to put a box, and then parentheses, x minus, and we're going to put a box. Okay, now, super important you catch this. This right here is the generic formula for point slope. Notice that in the generic formula, it's always y minus, x minus. This is going to come up a lot as we go through the rest of our class. So keep that in mind. Okay, now, let's fill in our numbers. Okay, so let's use the point 1-3, like we said. So y minus box. So in fact, we can let's write this information up above here. So this is y1, right? And this is m, and this is x1. Okay, so what goes in the y1 box? Okay, I'm going to put a 3 in there. What goes in the x1 box? Okay, a 1. And then what goes in the m box? Okay, 5/7, right? Well, yeah, what we're doing is we're using an example. We're starting here, we're going down to the graph, and we're coming back so that we can see how we can flow from one to the other. So if I give you an equation, you can graph it. If I give you a graph, you can write the equation. Okay? All right, so now let's clean this up a little bit, and we get y minus 3 is equal to 5/7 times x minus 1. That's where we got back. That's where we started, right? But Margo pointed out that there's more than one point. What happens if we use a different one? I don't know. Let's find out. So let's start with y minus box, which is our y1, is equal to box, which is our m, times x minus box, which is our x1. Hey, just for the fun of it, let's use the -6, -2 point and see what happens. Okay, hang on. Watch this. Let's just for the fun of it, let's see what happens. Go away. Okay. Well, I'm going to write it anyway. But here we go. What goes in the y1 box if we're using the -6, -2 point? Okay, this is -2. What goes in the m box? No. Okay, so that's still 5/7. That's still our slope. What goes in the x1 box? -6. All right, now, what happens when we go y minus a -2? Oh, negative minus a negative becomes a plus. So then if we were to clean this up, now our format is going to look like y plus 2 is equal to 5/7 times x plus 6.
Holy cow.
So which one's right then? Would seem to be, wouldn't it? I mean, they're both on a line. Let me ask you this. If you were able to look at this right here, and in your mind, you knew that the generic format of this starts with y minus and x minus, and you looked at this and you saw these pluses, could you go, ooh, I know that plus 2 came from y minus -2. And could you look at this and go, oh, I know that's supposed to be x minus in there. So if it's x plus, that means it must have been x minus -6. See what I'm doing? Right? And then could you pull the point -6, -2, put it on a graph, and rise and run 5 and 7?
Yes.
Would you get the same line?
Yeah.
Okay, so then they both must be the same, right?
You're right.
Okay.
I mean,
We'll take a deeper look at that later. But yeah, so here's the situation now. We have a bit of a problem. All right, in fact, let's write this. These are both correct. So we have a little bit of a problem here because the problem is like if I said to you, hey, give me a multiplication problem of two numbers that multiply to 24. Go. Somebody give me one.
6 times 4.
6 times 4. Somebody give me another one. 3 times 8. Somebody give me another one. 12 times 2. Somebody give me another one. What's that? 24 times 1. Give me another one. How about 1/2 times 48? How about 1/8 times 192? Oh, wait a minute. When I start bringing fractions into this, we could go on forever, couldn't we? Kind of like a line goes on forever. That was sick. Did you see how I did that? That was sick. Wasn't that sick? That was pretty good, right? I came up with that in the car ride here. Okay. All right. Hey, that's point slope form. Okay, so now I'll tell you this, okay? Listen, when you're working with formative, Isaac, you're going to want to get these right. So when you're working with formative, okay, I'm going to give you 2 points on a graph that clearly does not go through an obvious y-intercept. So I might give you a picture of a line that looks like this, and you might have 2 points on there, either these two or these two. You'll have to use one of those for your answer in point slope form. And I will have it set up that both of them are in there, okay? And actually, really what would be great practice for you is try doing it both ways. Like, try writing it this one and see if you get the point, then delete it out, then try writing it this one and see if you get the point. Because really, the hardest thing about point slope form, in my experience, is when these become pluses here, students forget that that comes from minus a negative. Really important that you got that idea. Everybody clear on that? Minus a negative. Okay, all right, good. Okay, now, let's talk about the last one, standard form. Here we go. Yes, question. Yep, you got 3, so I don't know where you're at. Good, yep. Yellow. All right, here we go. Standard form. Okay, So standard form, whoops, let's get a pen to write with, yellow.
Jade, you're so cute.
Used when we know the x and the y intercepts. Notice I said nothing about the rate of change.
So we don't know the slope.
Ah, okay. Also, this is used when we are comparing / relating two unique items. Like in a words problem, something like, I bought M&Ms and I bought Reese's peanut butter cups, and now I'm comparing M&Ms and Reese's peanut butter cups. I'm going to use those and use a standard form. All right, let's talk about standard form. It's a little weird. It looks like this. I'm not even going to shift this off to the left because there's really nothing to write, because there's nothing to read right off of standard form. Here we go. It's capital A, lowercase x, plus capital B, lowercase y, is equal to capital C.
The alphabet?
I know, right? Algebra and its letters. What's the point of that? All right, now listen. Okay, I just said this, but I want to reiterate this idea. This is important to understand, okay? Just looking at this right here, you can read the slope and y-intercept off of it, if you know how to read it. Just looking at this right here, you can read a point and the slope off of it. There is nothing to read off of this. You're going to have to do some manipulation with these numbers to get the information that you need. Okay, so let's do an example. Here we go. All right, so the example I'm going to give you is this. 3x plus 2y is equal to 12. 3x plus 2y is equal to 12. All right. Well, this is the algebra side, right? So let's be consistent with what we're talking about here. Heads. And of course, we're headed to tails. So to graph this one, which again is heads to tails, lock it in. Okay, so to graph this one from heads to tails, all right, we're going to find our x-intercept, okay, which we're going to write it like this. Okay, x-intercepts, right? That's where the line crosses the x-axis. So the y value is equal to 0. Does that make sense? Right? It's at a 0 height. So we're going to call our x-intercept lowercase a comma 0. Because the a is going to represent the x value of the x-intercept, and the 0 obviously is... No, because that you'll see why in a little bit. It plays into a formula. Okay? All right, but that's a good question. All right. Okay, so we got to find our x-intercept. Then we got to find our y-intercept. And we're going to write that as lowercase b comma 0. There's consistency there, right? Y-intercept, b, see it? Okay, all right. Okay. And then lastly, we're going to plot points / draw a line. Okay, so that should be pretty straightforward. Okay, yes. I'm sorry, it should be 0 comma b. You're right. You're right. It should be 0 comma b. See how smart you guys are? That's what I love about teaching this class. You guys are so much smarter than me. It's great. Okay, now we've done stuff like this. Well, I don't. We've done, but you've probably done stuff like this in Algebra 1. But to find the x-intercept, in fact, here we'll just do a little. Let's just do a little squiggle here. So we'll do the x-intercept on the left, we'll do the y-intercept on the right. So the x-intercept is where y is equal to 0, right? So we would start that problem off like this. We would go 3x plus 2 times 0 equals 12. So then 2 times 0 is 0, so then I get 3x is equal to 12. And I divide by 3 and I get x is equal to 4. And so that is the x value of my x-intercept, right? And so then my x-intercept is going to be at 4, 0. And in fact, I can even put that on my graph. 1, 2, 3, 4, 0. And then if we do the y-intercept, that's where x is equal to 0, right? So then I would do 3 times 0 plus 2y is equal to 12. So then that's going to give me 2y is equal to 12 and y is equal to 6. So now I have my y-intercept, the y value of my y-intercept, which is 0, 6, right? So then I can go 1, 2, 3, 4, 5, 6, put a point up here. And now that I have 2 points, right? So this is my 0, 6. I can now draw my line because as we learned in geometry, we only need 2 points to draw a line.
Jane is back. I miss you, Jane.
Yeah, well, and actually, we don't even really need m in this case because we have 2 points, right?
Yeah.
So the only reason why we needed an m was because we only had 1 point. It was either the y-intercept or it was just some other random point, and so then we had to rise and run to find another point. But if we have 2 points, well, then we can just graph them. Okay, so this is the one that is not taught very often. So let's talk about. Wait, I gotta highlight my tails, don't I? All right, here we go. Tails. All right, and then let's go back. Okay, so this is the one that gets a little tricky. As you can see. Go away. All right, here we go. All right, back to standard form. So back to standard form. So this would be if I gave you a graph and I asked you to write an equation and you would be looking at this graph and you would say, well, Mr. Vargas, that graph has x and y intercepts. So then you would know that this is the one that you should write in standard form. Okay. So again, we're going to find our a, 0. And then we're going to find our 0, b, our x-intercept and our y-intercept. And then we are going to use intercept form. This is not slope intercept form. This is intercept form, or the intercept formula. And we're going to simplify to standard form rules. We'll talk about what those are in a second. Okay, I'm going to move this up here. All right, so like we've been doing, we're going to do our box version of this. And so here is what the intercept formula looks like. It is x over box, and that's going to be our A, plus y over box, and that's going to be our B, is equal to 1. Yes. No, 1. I can show you guys why that works later. Okay, all right, now let's use the question above, and let's write our information in here. So what is the A value that we came up with from our graph? That's the x-intercept, the x-coordinate of the x-intercept.
4.
Okay, so that's going to be 4.
6.
And the other one is? 6. All right, now, let's rewrite our problem. So now we're going to have x over 4 plus y over 6 equals 1. Now we got to get rid of our fractions. Okay, so we're going to use our least common multiple to do that. We could use any common multiple to do that. Okay, but we're going to use our least common multiple to do that. So let's multiply both sides by, what do you think? What's going to blow up both of those fractions? What number could I multiply by that's going to cross cancel with both of those denominators in one swoop through the problem? No. 2 is going to leave me with a 2 on the bottom and a 3 on the bottom. I got to get rid of the denominators. I got to blow up the fractions. 12. That'd work, right? Because if I multiplied by 12 over 1, the 4 and the 12 would cancel, leaving me with a 3. And the 6 and the 12 would cancel, leaving me with a 2. And then, of course, I got to multiply the other side by 12.
That's how we got the
Oh.
That's where the 12. Wow, that makes so much sense.
Right? So then the 4 and the 12 cancel, and that leaves me with 3x. The 6 and the 12 cancel, that leaves me with 2y. And then 1 times 12 is 12.
Wow, how did I just do that? That was crazy, Mr. Marcus.
I know, right?
Crazy.
Okay.
There's so much room.
All right. Last thing we need to do. Let's just come a little squiggle over here, and let's say
We have a hole in our paper.
standard form rules.
Wait, I don't have room. Just write it right here.
Write it somewhere. Turn your paper over and write it on the back. Say see back. You could do that. Okay. Here are some standard form rules, things that we kind of these are what we call conventions, things that are sort of accepted about standard form. Number 1, x and y are on the left side of the equation. X and y are on the left side of the equation. Number 2, a and b are integers. No fractions.
On, go, what?
A and b are integers.
Oh, R.
Go away. No fractions. All right, and then number 3, A is positive. And number 4, no GCF
Bruh.
for A, B, and C. You can use the back of your paper if you want. It's fine.
I'm gonna try my best. There's only 4.
There's no GCF for A, B, or C.
Is that it?
That's it. Well, that's it for the rules.
I fit it.
Good. Okay, there's one more thing I want to talk about, and then we're gonna do some practice. I know, huh? I know, right? Okay, I'm just gonna come over here real quick. Okay. All right. Okay. Let's go back to this same problem that we just did a second ago. Let's go back to this same problem that we just did a second ago. Okay? And I'm going to rewrite this problem up here. X over 4 plus y over 6 equals 1. Okay? Now I'm just going to pick some number to multiply by. About like 24.
Why?
Well, because 24 will blow out both of those fractions. It doesn't matter what number I use, as long as it's a common multiple, right? So if I do this by 24 over 1, the 4 and the 24 are going to cancel, and what am I going to be left with? 6, right? So I'm going to have 6x plus what? Right, 6 and 24 are going to cancel, so 4y is equal to what? 24. Uh-oh. Are we in a situation where, again, we've got multiple equations? No, because we can take each of these and divide them by 2, which is the point of number 4, no greatest common factor. You have to divide that out of everybody, and that's how we get back to 3x plus 2y equals 12. That's the answer that you need to put in formative.
So if we didn't see it like right away and we just used 24, would we like get it wrong?
If you type in 6x plus 4y equals 24, yeah, you're not going to get full credit for that.
But it's okay if we do that and then just divide it.
As long as you take out and that's why I made that point of number 4 is that there's no greatest common factor between the A, B's, and C's.
Before you even start doing your math, can you just divide it all by 2? Like, can you divide 4 by 2, 6 by 2, 24 by 2? Then you get it like how it is. So it would be 12, and then x over 2 and y over 3.
If you did no, because that wouldn't. You're not dividing numerators like that. Because if you try to divide those numerators, you have to do it equally to both sides of the equation. And when you divide a denominator by a fraction, you're actually doing a multiplication problem in the denominator. Yeah, so just stick with the easy way. But good question.
Why do you leave the spaces in one? Do we have to do that?
How do I leave a? Oh, you mean just this gap in here, right here? That was just my hand. That's just my sloppy handwriting. Okay, you got it? Okay, so now you should be able to go from your equation to a graph or from a graph to an equation in all 3 formats. Again, just to kind of reiterate when you're doing this. Oh, I didn't write my tails. Tails. Okay. All right. Hey, listen, real quick, just to kind of summarize, okay? Just to reiterate. Again, know why each of these applies to certain situations, okay? And then we're going to use them accordingly. And then know how to go from heads to tails and tails to heads in each one. All right. Now, before we get out of here, we're not done. I want to do a couple of the homework questions with you to make sure that you're tracking on what we're doing here. Okay, so grab out your iPads because it is on formative, and we'll do a couple of these together. Or at least we'll talk them through so you get an idea of what we're doing. Okay, so I want to talk through a few of these questions together with you just to kind of make sure that you're seeing how they come into play. All right, so the first one, use the graph in the Show Your Work section to answer the questions. Which form of a linear equation is best suited for this line? And so you're going to type in for your answers, and make sure you type them in like they look here to get them right. Point dash slope, slope dash intercept, or standard. Those are going to be the 3 answers that you're going to use in that first one. And then I want you to tell me why. Why do you know which one that is? And then you're going to write the equation of the line in the form that you chose above. Okay, so let's take a look at this one here. So, question, you got to make an assessment before you write the equation, all right? So, the question is which one of our 3 formats do you think this works best for? Right, because we have a clear y-intercept, and we have another point that we can use to figure out the slope. We don't have 2 clear x and y-intercepts, right? And because we have a clear y-intercept, we don't need to use point slope, which is more complicated anyway. So let's just jump to the easy one and write in point slope. So or slope intercept. So slope intercept is our format we're going to use. Our y is because I have a clear y-intercept. Go ahead and put that into your formative. So the format is slope intercept. That's what you're going to type in. And then because I have a clear y-intercept, that's why you're using that. And any of the explanation questions, just so you're aware, you're not going to get a point for right away. That's not until afterwards, okay? Then once you have that, I want you to write the equation of the line. Let's see how you do. Go for it. Look at this question. Which one do you think this one is? Yeah, this is point slope, right? Because we don't have a clear y-intercept. which means we don't have an x-intercept and a y-intercept. And so this is point slope. And so I'll let you work through that one. All right, I'm moving you forward. Yep, here we go. I know. You'll get to come back. Don't worry. Okay, let's take a look at the next question. Okay, good. So you can see very clear that you have an x and a y-intercept, so that makes this standard form. Fantastic. Let's move forward. Say what? What's going on here? Uh-oh, this could be trouble.
Oh my gosh, it tells the heads.
All right. So let's think about this one for a second. Actually, I'm going to go out of the show your work. All right, you ready? Let's talk through this. Ready? A jewelry shop sells charm bracelets with many different charms to choose from. Nothing mathematical there, but okay. They charge a base price, that should tell you something for the bracelet, plus $12 per each charm. That sounds like a rate.
Wow, that's expensive.
$12 one charm. $24 two charms. Okay, all right. Okay, that sounds like something. Logan bought his grandmother a charm bracelet for her birthday. He selected 3 charms and paid $91. So I have a clear relationship between number of charms purchased and cost, 3 and 91, and a constant rate of change. Is that clear information a y-intercept? No. What point is it? It's 391, isn't it? Right, 3 comma 91. Okay, so then what would be the format we're going to use for this one? This is point slope. And what point are you going to use? 3 comma 91. Okay, good. You get the idea. All right, fantastic. Let's take a look at the next one. Okay, here we go. Next one. A construction crew has been hired to remove dirt from a lot. Before beginning the job, there are 8 tons of dirt to be removed. The crew begins removing dirt at a pace of 3 tons every 4 hours. The time the crew works can be tracked on the horizontal axis of a graph. Which form should we use? Why slope intercept?
You have slope and the y-intercept.
What is the y-intercept? Why is that the y-intercept in the context of the story?
Because it's before the job is done.
So how many hours has the crew worked? No.
Oh, right now
0. They've worked 0 hours. How much dirt is left? 8 tons. Right? And after they work 4 hours, they will have removed what?
3 tons.
See what I'm doing? Okay? All right. So yeah, so that one's going to be slope intercept form. Well, I'll let you figure out what the slope is for that one. Let's look at the last one. Okay? Because we're almost out of time. Let's look at the last one. A banquet hall has 2 types of tables, rectangular and round, 2 unique items. The rectangular tables fit 8 people sitting at them, while the round tables fit 6. 1 rectangular table has 8, 2 has 16, 3 has 24, 4 has 32. Get what I'm doing? Okay. The banquet hall is hosting an event for 192 people. What format are we using? Standard. Okay. You got the idea. I think you can do this. Monday. Have this done by Monday. See, you didn't even know that you were here. Because, it went so fast, huh? Because you're just doing math the whole time.
Did you get my email?
Oh, did I just do that? Bummer.
Did you get my email about...
Hold on 1 second.